All right, Form 2s, checkpoint students, we are now doing chapter 15 for our maths. We know that we only have 15 chapters to cover for stage 9. So here's the last chapter for stage 9. And we want to quickly master the things that you have to know for this chapter. And we move on, okay? So let's go for it. Let's quickly go through the things that you need to do for stage 9. Then we're going to do a lot of questions that I've put for you here. And after we do those questions, we'll try to see some past paper questions to do with this chapter 15, okay? So, chapter 15, you know what it is about? You need to know different things. You need to know what we call a frequency polygon. That's the first thing. Then you need to know what we call a scatter graph and how to make it, okay? Then you need to know a back-to-back stem and leaf diagram. These are 3 things you should know. So these are the first 3 diagrams you must know. Then after you know these 3 diagrams, we'll talk about how you'll be finding mean and whatever median when you have grouped data. Then we'll talk about some other things in representation of data. So the most important things, we start with these first 3 things, then we'll do 2 other things, okay? So a frequency polygon, I need all of you to know what a frequency polygon is and how to make it. And then I need all of you to know a scatter graph. Then I need all of you to know a back-to-back stem and leaf diagram. Are you ready? Let's go for it. So this is what it's showing you. You must be able to do frequency polygon as the first one. Let's go and look at it. Then after that, we'll do scatter graphs. Then after scatter graphs, we'll do stem and leaf diagrams. And we'll be done with those first 3 things. Then we can move on to the other things. All right, so let's go for it. Well, before we do that, before we talk about our frequency polygon, what I want you to know is that this is called statistics. You're going to do this chapter again when you do your IGCSE. It's one of the last chapters. It's called statistics, okay? It's the very last thing at the end. This statistics, first of all, you must know that we are dealing with data. So it's like we want to know about the ages of children at a school. So we walk one by one and we'll be asking them, hello, how are you? What is your name? Oh, my name is Maya. Then you write Maya Johnson. Then they say, then we say, what is your age? Then they say, okay, my age is 14. So we write Maya Johnson, 14 years. Okay? Maya Johnson, 14 years. So this is going to be the age. So now we'll look around. Hello, what is your name? Then they say, oh, my name is Loreen Dixon. What is your age? Well, my age is 14 years as well. Or my age is 10 years. So you have this one was 10 years. And then you move around and you write down the data of all these people. This type of data that you're collecting, we will need to know what type of data it is. Before representing data, you must identify what type of data were we collecting. Because you'll be collecting different types of data. Now, after collecting all this data, maybe it's people's height, or it's the mass of all students in a school, or the ages of all students in a school. So you've just collected this data. Now you want to represent it. To represent it means you now want to show it on graphs and stuff so that people can be able to understand. Because you want to explain to people to say, this school has people that are taller than this school. This school has kids that are older than this school. All those things you want to compare. This class has people that can run faster than this class. So you want to compare. Now, for you to compare, you need to represent it, to show it on graphs and stuff. Before we can do that, before we can do a frequency polygon, because a frequency polygon will help us to understand certain things about the data. Before we do a frequency polygon, before we do a back-to-back stem and leaf diagram, before we do a scatter plot, all these things are going to be important, but we need to know what type of data it is. So now let's see the types of data. You need to know the types of data so that when you have collected data, you can tell them what type of data it is. Here, we have 2 main types of data. We have 2 main types of data. One is called discrete data, which means data that is only made up of whole numbers. Data that is only having whole numbers. So if you have collected data like things that can only have whole numbers, like the number of students in classes. Can you have 1.5 students? Can you have 1.25 students? No. It can only have whole numbers. So because of that, it's discrete. So I need you to know that there are two types of data. Two main types of data. One is discrete, which is data consisting of separate values that are counted. So discrete is whole numbers, and the reason why it's whole numbers is discrete data, you use it when it's for things that you count. The number of students, you count things, the number of cars that pass somewhere, the number of trees, the number of classes, the number of things, you count them. 1, 2, 3, 4, 5. You can't have 1.5 things that you're counting. So when we're counting, we get whole numbers, and that's discrete, separate values. Here, number of students, the goals that have been scored, the number of books on a shelf, the number of cars in a car park. They can only take whole numbers. They cannot take every value. Okay? So discrete data is to represent counted values. Okay? If anything is counted, then it is discrete. Then the second type of data is called continuous data. Students, the second type is called continuous, and this is for measured things. So for measurements, not for things that you count. When you measure the mass, when you measure the distance traveled, when you measure the time, when you measure the temperature, when you measure the rainfall, things that you are measuring. Hey, can you please come here and measure the height of these students? Can you measure the mass? Can you measure the amount of time it takes for people to run? You are not counting? So it's called continuous data. Continuous data is data made up of measurements. It can take any value. Decimals are possible. You can have 1.25 as the height of a person. You can